Hello again. We are just going to finish up 2.1 day 2. You can probably do both these sets of notes in one day, but that way our video is a little bit shorter. So we're comparing numbers in scientific notation. Go ahead and pause it and do your warm-up. When we're comparing numbers in scientific notation, there's two ways to do it. You can either change it into standard form like we did in the last section and compare the two numbers because you know how to compare two numbers in standard form, or you can use these types of techniques. Okay? The first technique is if the exponents are exactly the same, you just look at the bigger exponent. Okay? So if I have 10 to the third and 10 squared, the number with 10 to the third is obviously going to be bigger. Or if I have 10 to the negative 5 and 10 to the negative 4, negative 4 is bigger than negative 5, so that number will be bigger. Okay, so that's why that note here is be careful with negatives, okay? Understand which negative is actually bigger. And this set of notes is already typed up in your note sheet, so you shouldn't need to be writing this for very long. Okay? The second technique, which we're going to talk about in actual examples in a second, if the exponents are the same, then you look at the coefficient, which remember is the number in front of the times 10 to the whatever exponent is bigger. So then you would just, if the exponents are the same, look at the coefficient, whichever number is bigger in the general sense, that's the bigger number overall. And again, still be careful of those negative numbers. So our first example here is 5.6 times 10 squared and 2.1 times 10 cubed. So I see my exponent powers here are different, so I have 10 squared and 10 cubed. And I know that 10 cubed is bigger. So therefore I know that 2.1 times 10 to the 3 is bigger. Okay, so if they're different exponents, you just look at the bigger exponent. That number is bigger. If my exponents are the same, such as this problem here, so I have 10 to the negative 1 and 10 to the negative 1. So I look at my coefficient. I have 3.4 versus 1.1. And I know from experience that 3.4 is clearly bigger. So 3.4 times 10 to the negative 1 is also bigger. So if the exponents are different, you look at the exponent powers. If the exponents are the same, you look at the coefficient power. So on to another example. So we have 3.5 times 10 to the negative 3 and 3.5 times 10 squared. Oops, sorry, you guys can't see that. And I can tell there that my exponents are different. And I look at negative 3 versus 2. And I know that 2 is bigger than negative 3. Remember, that's why I said be careful of those negatives. So then I know that 3.5 times 10 to the second power is bigger. Okay. And then my next example here. Make sure you're pausing whenever you need to. It's a word problem, but it's still the same idea. An actor has 75.126 fans on social media. A musician has that is not a decimal. This is 75,126 fans. So let's reread that. An actor has 75,126 fans on social media. A musician has 8.58 times 10 to the 4th fans. This is an actual multiplication symbol. So who has more fans? So if you notice, when we're comparing these two things, I just want to know which one's bigger. I have 75,126 or 8.58 times 10 to the 4th. Now if you notice, 75,126 is in standard form and then 8.58 is in scientific notation. So the only way it works is if both of them are in the same form. So what you could do is, since this one's in standard form, I could change this one into standard form. And I'm actually not going to do it that way because I think most of you can convert this to standard form pretty easy. I'm actually going to convert this one into scientific notation just because I think most of you would have a harder time doing that. So my decimal is technically here. If I move it here, 7,512 is not between 1 and 9. 751 is not. 75 is not, but 7 is. So I have 7.5126, and I made a bigger number smaller. So if I wanted to start from here, I would want to make this bigger, so I need to multiply it by 10 to the 1, 2, 3, 4 spots. So it's to the 4th power because I went from a bigger number. So I want it to be bigger when I'm actually done with it. Or I'm comparing that to 8.58 times 10 to the 4th. So now if I look at it, I can see, well, oh, here's my other color. 10 to the 4th and 10 to the 4th are the same. And I look at the numbers in front, 7